Hi guys, in this video we are going to learn another interesting question for finding the speed. So in the previous question we have discussed whether that method suits for all type of question to find the average speed if they have given the speed for certain number of time periods. So here we are going to discuss a question similar to that, but here you can't use that method. That's the catch. So what's the question? So there is a vehicle which is moving in a linear motion, which means it's going to move in a straight line. And also they have given that it's going to move with 60 kilometer per hour 60 kilometer per hour for the first half distance. So remember, for the first half distance, and during the next half distance it's going to move with 40 kilometer per hour. So in the previous question we have taken the time for the first half time interval or time duration, it moved for 60 kilometer per hour, but here we are going to take for the first half distance it's moving with 60 kilometer per hour. So please pause the video and try it in your own. So here comes the question. In the previous question, we have taken a variable name called T naught, where we denote that the total time taken for that traveling period as T naught. Here we actually use S instead of T. The reason is here we are going to deal with distance, not with the time. So here we are going to take, let's say for the first half, which means for the x by 2 distance, it's going to go with 60 kilometer per hour. For the next x by 2, it's going to move with 40 kilometer per hour. You can take any name. For the simplicity I have taken like S, or you can use D also, it's distance or D. So here let's mark that in this diagram. So that's the main point you need to do, as I have already mentioned. So I'm going to mark like this. Since it's a distance, I'm marking like this. This is S by 2 and this part is another S by 2. So the next point is we actually don't know the time there, so that's the main problem. Let's say this is t1. I don't know whether we need the time here or not, but let's put it like this. So actually we don't know whether we need this or not. So next point is here we can tell here is going to move with 60 kilometer per hour, and for the next part it's moving with 40 kilometer per hour. So these are things we can directly mark on this. So the next point is we need to check whether the equation. So I hope we have now finished our first step. We have clearly plot the diagram, and the next part I'm going to give the next part for you guys. So please pause the video and try it in your own and find the average speed of this total travel. I hope you have given a try. So when you're considering about the average speed, actually we have already learned when you're having these kind of questions, you need to remember the equation. So it's going to be total distance divided by total time. So I have marked it like this. So now we need to find the total distance. Can you figure it out? What's that? What's the total distance? So we have taken as S from this point to this point. So we are moving with S distance. So what we are going to do is, for the total distance, I am going to mark it like S. So here comes the next question. We need to find the total time taken. But that's the catch. We don't know what's the total time taken. So how to find that? So we need to use this 60 kilometer per hour and this 40 kilometer per hour, the data they have given. Otherwise, we can't actually complete this. So can you figure it out? What's the time interval taken for this S by 2, the first half distance, for traveling the first half distance using this? Please pause the video and try it in your own. I hope you have figured it out. So let's mark it like this. The total time is t1. So actually, let's say this is for this time interval, they are taking like t2. You can actually put anything, but for the easy of understanding, I'm putting like this. For the first time interval, we are taking t1. For the next time interval, we are getting t2. Okay. So here, actually we knew that, let's write the definition for the velocity. So for the velocity might be the speed because it's going to move in a straight line path. So displacement and distance would be same with the magnitude. So when you are considering about that, 1 hour we are going to provide, or we are going to travel for 60 kilometers. But now we are going to turn it in the other ways, which means for 60 kilometers it's taking 1 hour. So we need to find for x by 2 kilometers how long it will take. So how to find that? It's like a mango question we have already did. So the 60 kilometer we are taking 1 hour, so that we are going to multiply by x by 2 kilometer. If you do so, you are going to get s by 120. If you directly multiply by this, kilometer would be cancelled in this x by 120 hours. Likewise, you are going to find the value of t2. So please pause the video and try it in your own. Hope you have figured it out. So I'm going to write the same steps over here. 40 kilometer for 1 hour, so that we can tell for another x by 2 kilometer it's going to take s by, I'm going to write it directly, it's going to be s by 80. So here we come for the final part. It's going to be x divided by, for the t1 I can put it like x by 120. For the next part it's going to be x by 80. So we need to simplify that. So I'm going to use this space. So if we take, so this is a fraction, so you need to simplify that. So I'm going to take 240 as common. So if I take 240, it's going to be 2s. Here it's going to be 3s. So that, let's write it over here. S 2s plus 3s is going to be 5s. I'm going to take this 240 above. It's going to be like this. So finally we are going to get 240 divided by 5, which is going to be 48. Hope I haven't made any mistake. So it's going to be 48 kilometer per hour. So here you can't actually use that 60 plus 40 divided by 2. The reason is, you need to remember, if the time period of that velocity is given, or the of that speed given are same, you can actually directly add their velocity and divided by their time, or divided by the partitioning time. Let's say this is half, you can directly divide it by 60 plus 40 divided by 2. But here we have taken not the time interval, same time interval, we have taken the distance covered with the velocities are same. So that's why we are going to go with the flow, with the equation, with the definition, and we are going to derive the final answer. So you don't need to memorize these things, but you need to remember, if you are asked a question in physics, remember, it would be very easy. First of all, you need to understand what's happening. It's very easy if you can draw a simple diagram and plot all the details they have given. At the next point, use the equation with the which we derive directly from the definition, and use that. Here I need to tell another interesting point. So is there any way to find the velocity like this? It's a little bit longer to do that. So is there any method? Yes, there is a method. We are going to tell like this. We actually knew that when you are considering about the speed, so I'm going to write it like speed. Let's say that is b. This is speed or velocity. When you are considering about the linear motion, the velocity is going to be equal to speed. So for the simplicity, I'm going to put it like this: v. The velocity, actually we knew that, or the velocity, let's say speed, it's not going to be a problem. So that speed is going to be distance over time. That's the equation we have learned. So how to use this equation to find this interval? It's by 120 hour. It's very easy, so I'm going to do that now. So I'm going to remove this. So I'm going to use v is equal to s by t. So actually we knew that the velocity of that first part is 60 kilometer per hour. So I'm going to write it like this, 60 kilometer per hour. And the total distance s for that half time duration is, it's going to be s by 2 kilometer divided by, we actually don't know the time, so I'm going to put it like t1, and you need to just cross multiply by the t1. You are going to get t1 is equals to s by 2 divided by 60, and you are going to get a unit of hour. So if you simplify this, you are going to get s by 120 hours. So you can actually use this equation and find this answer directly rather than getting all the things and write it down one by one. So this is an easy method. But always remember, you can't use this equation for all the time. You can use only when that particle is moving with a uniform velocity or uniform speed. In other terms, it would be great if you can use the term speed. If it's moving in a uniform speed, which means, let's say the particle is moving with 60 kilometer per hour, which simply means in every hour it's going to move with 60 kilometers. So it's a uniform motion. So every hour, when you're considering about the every hour, it's going to move with 60 kilometers. So likewise, you can use this equation if it moves with uniform speed. We will learn another equation, how to use this type of equation, linear motion equation, when the particle is accelerating. So in the next videos we will probably learn that. So you can use this equation only if they have given it's moving with that uniform speed. So here they have given it's moving with 60 kilometer per hour, which is going to be a uniform speed for that s by 2 distance, so that we have directly used this equation. There is no wrong. I hope you have understood this part. In the next video we are going to learn another interesting question from speed. See you in next video. Thank you for watching.